Muy buenas tardes. Soy Valeria Foncea, periodista y gerente de comunicaciones del Observatorio Astronómico ALMA. Quiero darles la bienvenida a una nueva actividad de Puerto de Ideas en Vivo, un espacio en que todos los martes estamos invitados a reflexionar sobre el mundo de hoy y a imaginar el del futuro. La actividad que nos convoca es presentada en conjunto con Escondida VHP y tiene como invitada nada menos que a la astrobióloga franco-estadounidense Nathalie Cabrol. Nathalie es doctora en Geología Planetaria y Ciencias de la Tierra por la Universidad de la Sorbonne. Más tarde se unió al Instituto SETI, dedicado a la búsqueda de inteligencia extraterrestre, con sede en Silicon Valley, donde asumió en 2015 la dirección del Centro Carl Sagan de Estudios de Vida en el Universo. Su investigación se centra en explorar la habitabilidad y la vida más allá de la Tierra, tarea para la cual lidera proyectos en astrobiología, desarrolla estrategias de exploración científica en Marte, Titán y las lunas heladas del sistema solar exterior, diseña experimentos de campo con robots, entre otras muchas iniciativas. Como parte de este objetivo ha venido varias veces a Chile para investigar en el desierto de Atacama las señales que permitirían detectar vida en Marte y debido también a esta especial y espacial labor, posee el récord mundial femenino de buceo en altitud, prueba que también pasó en Chile. Pero ¿por qué tanto esfuerzo dedicado a Marte? Ya nos detallará, pero les adelanto que para nuestra entrevistada de hoy, el planeta rojo es nuestra memoria. Pues podría hablarnos de los primeros días de la vida en la Tierra. Es la razón por la cual la NASA acaba de lanzar Perseverance, un vehículo que se espera aterrice en febrero próximo en un cráter de Marte. Muchas gracias, Nathalie, por acompañarnos hoy desde tu oficina en Mountain View, California. Bienvenida.
Thank you very much for having me.
Muchas gracias.
Now I translate into English. After being able to watch
Después de haber visto la primera imagen de un hoyo negro, creo que el siguiente sueño de la humanidad sería encontrar un planeta que pudiera...
How far away you think we are from that target?
It is an interesting question because we are discovering a lot of extraterrestrial planets these days. The Kepler mission and some of the instruments, not the ones that you have behind you, but ALMA is also part of that quest, obviously. And Kepler had a little bias towards bigger planets, and it's just because of the instrument, because of the mission. But as we go and we have, better instruments, we are going to find planets that are the size of the Earth. This size is not everything. You have to be at the right place around the parent star, and you also have to have the right ingredients. But there again, what are the right ingredients? There is life as we know it, and maybe something else. But it's a very, very exciting journey that we just start now. I think we are much closer than we ever were, which is pretty obvious, but we are making progress fast.
Following that path, how technology is key for the detection of life. In fact, your first contact with Chile was remotely controlling from the US the NOMAD rover experiment on Mars, deployed in the Atacama Desert. And now that rover is on display at the Museum of Desierto de Atacama in Antofagasta. So what do you think about that technology for the detection?
Well, this is key. Right now, we don't have quite yet the capabilities to deploy humans on Mars. And to search for life, it's very clear that the human brain is far superior to any robots. But at the same time, we are a very fragile envelope, and we cannot stay as long as a robot outside, for instance, under the UV radiation. Ultraviolet radiation can be deadly after a certain dose. And there are also tedious tasks that are a problem, repeating them over and over again. So it's a trade-off. And technology right now is how we approach the search for life in the solar system and also on solar planets. So technology is paramount. And to test it, we have to go in places such as the Atacama, the Altiplano, or the Andes, which are extremely good analogs for Mars. There are other places that are good analogs for the icy moons, etc. But for Mars, this region of the world is particularly good.
Your first time really in Chile was in 2002, I understand.
This is correct.
Okay, as part of your mission in extreme places, you were all around, I guess. It seems that was more fruitful than was expected for you, which made you to return many times to the Atacama, the Andes, and the Altiplano to see how life adapts to extreme environments. You have said that you feel at home here in Chile. How can that be, being in such harsh places? How was your experience in like Kabul volcano, for example, 6,000 meter high? Can you tell us more about that?
I certainly can. It's interesting how I was born near Paris, so it's even more extreme than you can imagine. If I look at my background, there was really nothing that was preparing me for this kind of exploration. Pretty much nobody in my family knows how to swim to start with. I don't think that too many approach a mountain or anything. And until early in my 30s, I was not much coming out of my room. I was more writing, and my exploration was an intellectual exploration on the paper. But my first contact with the Atacama was through the eyes of nomad. And from the day I discovered the landscape of the Atacama through the camera of nomad, and I was in California, the love story started there. You cannot explain those things. It was really, in that instant, something was calling me. And from that moment on, I tried to find a way to physically get there. And so I wrote a grant proposal, and one was selected in 2002. And when you said, more fruitful than I was expecting, it is true and it is not correct at the same time. What I did was to find a way to get there, and I didn't know what to expect. But I knew one thing for sure, which is to show that scientists can be really, really, really wrong. I know for sure that the condition had to be so bad for life as we know it, that probably it wouldn't be a long project. The idea was to look at the environment, and I knew because it was so high and because of the geography that there should be a lot of UV radiation, lots of nasty things. And so my idea, of course, not being a biologist, was that, well, there shouldn't be much life around. And of course, when we arrived in 2002 for the first reconnaissance, the first thing we found was 100 square kilometer field of stromatolites. So from that point on, it became a journey that continues on today, that has taken me to the lakes in the Altiplanos, but also at the summit lake of Licancabur.
How many times have you been in this country?
Since 2002, the Hilux project, which is the one you are referring to, started in 2002 and ended in 2009. I've come in between that for a rover field experiments for reconnaissances, and also to deploy the planetary lake lander, which was a rehearsal for a mission to Titan, to the lakes of Titan. And then we had a more recent project in 2015 up to last November. And this one is an astrobiology project, and which is for biosignature detection, especially connected to the Mars 2020 mission.
Okay, we're gonna go that way too.
So on and on, it's been 18 years.
Wow, that's a lot.
Made a lot of friends in the process.
And you learn some Spanish, even if we are not practicing it now, isn't it?
I don't practice it. I try to, it's not that I am avoiding, but I have a sense of a ridicule, and I have an Italian grandmother. So few sentences into it, I'm mixing Italian and Spanish. That's okay with my team. We have an Esperanto that we've developed, between English, Spanish, and Italian, but I'm not sure it will be well suited for today.
Okay. I want to come back again to the Licancabur volcano, because you had an amazing experience, as you mentioned once before, diving, scuba diving. Did you get the record of scuba diving at the highest altitude because of that? Can you tell us more? What did you find there? How was that you get there?
Yes, Licancabur is definitely something special in my heart, in my life. And obviously, when we went there, the only thing I knew was that Johan Reinhardt, who was an archaeologist, went with his team in 1986, and his team set the world record for scuba diving. But at the time, I was not scuba diving, and I am a free diver. And I did not intend to scuba dive in the lake. And so we went there, and in 2003, we did our first free diving, which means that we're not using any breathing apparatus, right? You know what free diving is. You're only using your lungs. And it can look insane, but I have an explanation for what it is. We were doing this way. But anyways, in 2003 and 2004, we did free diving reconnaissance at Licancabur, because we wanted to understand the type of life that can survive there. And there again, I had a bias thinking that there would be not much out there, and was very, very surprised to discover that there is a lot of life out there. It's microbial. It's also zooplankton, which means little tiny microorganism, a little bit more complex. But there is a lot of life. It's abundant, but it's not diverse. And this is very important for planetary exploration, because it shows that extreme environment tend to filter life and only keep the organism that can survive and adapt very, very quickly. So after a little while, and although I am a pretty good free diver, it was very clear that the lake was so interesting that we needed to have more time at the bottom of the lake. Because one thing is sure is that you don't want to come out of a lake at 6,000 meter elevation without air in your lungs, because now you have to catch your breath in half of an atmosphere. And I had to do that once, and it's a very, very unpleasant experience. So it's for this reason we organized a scuba expedition in 2006. And it was not a conventional scuba expedition. We realized that at this elevation, it is safer to go with pure oxygen than to go with a mixture of gas, because we had no idea. The water, the diving table at this elevation are just totally off the chart. Nobody knew, what they could be. And if there is something that is sure, is that oxygen is a good thing at this elevation. Oxygen, if you breathe that, is not going to harm you. You don't take any risk. And when you are at altitude, the thing that's lacking the most is oxygen. In fact, NASA and our safety review board was concerned that after breathing that much oxygen, during that 20 or 30 minutes the dive was lasting, when we went out and removed the oxygen, we would pass out. Oops. Just because of the difference with the atmosphere. So what they did was to put us on medical oxygen once we got out of the lake. So we spent a lot of time breathing a lot of oxygen, and you can imagine we were in a tiptoe form. We were running all over the place after that. But diving at Licancabur was an absolutely amazing experience. Scientifically, personally, it was incredible.
Why was so important scientifically speaking?
Because we realized that, as I said, life was abundant. So lots of life. And this is not something that I was expecting, but it was not diverse. And the thing is that 30% of all the species in that lake were composed of 4 species, 30% of the whole population of the lake. And when we did the chart of their genetic history, we realized that they were all cousins of each other. So what that says is that you have probably a handful of very successful species, and they are capable of adapting very, very fast. But then it's not going to be diverse. All other species, as conditions are changing, they disappear.
Yeah, okay.
And this is one thing that we are facing right now with climate change. It's one of the issues that we have, where we have all over the world, and it's not about only extremophiles. It's about all of the species. We are losing biodiversity, and this is extremely sad.
Absolutely. Well, you were working for years with the SETI Institute team, developing new biosignature detection and exploration of strategies in support of the upcoming Mars 2020 mission, as it was far away. But how do you feel now that the mission is finally traveling to Mars right now?
Well, the project that was dealing with that, we are actually just finishing it, so it's not too far away. When we were at the HYLEX project was more to understand what type of habitable condition could have been on Mars. And with this new project that we have been working on for the past 5 years, we were looking more at how do you detect biosignature in this type of environment. So we switched a little bit the focus on life. And so we did that in the past 5 years. And the premise of the project is that as you change the focus of the investigation from the characterization of habitability, which can happen at a very broad scale from orbit, and in a few places only, 3 places on Mars with rovers, now you are searching for life. And when you look at the history of Mars, then it has to be, Mars was an extreme environment from the get-go. It was a very, very harsh place, and it became even more extreme very fast. So it's not like we're expecting a lot of biomass will have developed, at the surface of Mars, for instance. And we are expecting that life would it would behave like it does in extreme environment, which means that you will find it in extremely isolated oases. And when I say isolated, they can be only centimeters large. I am not talking about big field. You also have big fields of stromatolites or life in salt deposits, but oftentimes you will also find life in small areas. And those areas, the only thing that's common between them is because the metabolic activity of the microbes who are there can happen in those places. And so you have to try to figure out what those places are at a scale that matters for microbes. So this is not the scale of the orbiter. It's not the large scale of big images and big spectra, etc. It's the micro scale. So what we wanted to do was to find a way to bridge the scale of the orbiters and the data and knowledge we have with the scale of the microhabitat. So we have been busy doing this for the past 5 years, and we simulated missions to Mars using the same type of orbital imagery, for instance, and using the same instruments on the ground that Perseverance will have, or other rovers in the past did have, to understand the mineralogy, the composition of those microbial habitat, trying to understand where they are, what are their signatures, and also trying to understand how we can follow the data and track them down between orbit to the ground. And in the process, we made some very interesting findings. So this is what we were busy with. And it's complete change of perspective. If you want to find microbes, you have to become the microbe. This is always what I'm saying. You know, you have to become that microbe and say, okay, where am I going to live if I want to survive in that place? I need a shelter, I need energy, I need water, a specific type of mineralogy, et cetera, et cetera. So fascinating work and some guidance for the coming mission.
A lot of work ahead, I guess. You have said that even if we don't find any Martian, let's say, Mars is a good place to find out more answers about life in the Earth. I would like to understand if curiosity is still in Mars. In fact, a week ago, it celebrated 8 years over there. Why the same team of engineers worked to send another spacecraft as a Perseverance? Why to continue sending?
Just because we haven't been looking for life yet. And so this is something that is a little difficult sometimes for the public to understand. There is only one time in the whole history of exploration of Mars where we actually did search for life. And that was the Viking mission. And that was back in 1976. But at the time, we had no idea about the environment, the type of environment that Mars was. That was the very first mission to land there. And the only images we had were before from the Mariner mission. And the detail at the surface were between 200 meters and kilometers. So the resolution was very poor. We knew nothing about it. And so when some of the biological experiments landed there and got some result, they were very ambiguous. And in fact, some people said, we found life on Mars at the time because there were a number of reactions that looked like it. But years after that, and analysis of an environment we know a lot better now, we think that it's more of a chemical reaction because of the oxidizing environment of Mars, that it was not life at all. But because the results of the Viking mission were so ambiguous, then NASA decided to go and develop an integrated program of exploration, one that could give us a good understanding of what the environment was in the past and in the present. So we sent Mars Global Surveyor, all right? And we did the first orbital mapping, the geology, etc. And then Mars Odyssey to get some ideas of the climate in the past and in the present. And there you have it. It's an integrated program that little by little gave us an understanding of the environment on Mars. Why is that important? Because life and environment co-evolve. And if you don't know what the environment is, you will have a very, very difficult time understanding if a reaction that you have to an experiment is because of the environment or because of something else. That could be life. So until now, and including curiosity, we have been characterizing habitability and environment. We have not looked for life yet. And the only other thing that sometimes is a little confusing is that people see that with Curiosity in particular, but also from space and the European Space Agency mission, we are finding lots of organics on Mars. But organic molecules are not life. Organic molecules are the bricks of life. So now you imagine, it's just like Lego bricks. You know the Legos?
Yeah.
So imagine that organic molecules are that. Your Legos in the box, they are just run like that and they are nothing. But then when you assemble them, you can build anything you want. And that's the same thing with organic molecules. Some of them will stay as just that, bricks. And others will, after 4 billion years, link to something looking like you and me. All right. So there is nothing looking like you and me at the surface of Mars. Maybe me, because I've spent so much time, poring over the data, that maybe I have a clone out there. But what I'm saying is that right now, organics are just that, the bricks of life. We don't know yet if they assembled into something more complex. And this is what Perseverance and Rosalind Franklin, the rover from the ESA mission, and also the Chinese rover, which I think is still waiting for a name right now, are trying to find out.
Now I understand. Thanks. Coming back to Perseverance, the spacecraft, it will arrive very soon in February on Mars to look for microbial signature, carrying a drone that was tested in the Andes, as I understand, and an ExoMars drill that can probe 2 meters. Both are exciting missions, but they're also, it carries 23 cameras, including zoom capabilities for the first time, and 2 microphones. Why microphones? Can you tell us more about those so interesting devices?
Yeah, having a microphone on Mars is an old dream. For the first time, you'll be able to hear the wind on another planet, hearing the sound of sand, passing by on a rover. And I think that it will consolidate in people's psyche the fact that Mars is very similar. It's always what I'm saying. You don't need to invent any words to describe Mars. You talk about the wind, you talk about dust devil, molinos, you talk about valleys, channels, polar caps, volcanoes. You don't need to invent anything. But this similarity stops when you say, yeah, but there is no atmosphere, or pretty much no atmosphere. So that's an issue for us. But I think that having a microphone is going to, get us effectively even more close to Mars, because we will recognize those sounds. It was already incredible when InSight recorded those Mars quakes. And so we were able to translate some of that into sound, but it's not like hearing really something. So this will be something incredible. And the other thing is that for the first time, we'll be able to hear our rovers working. We never were able to do that before. So yeah, it's people can say, so what, okay. But there is some engineering importance to that too, because our eyes are not the only thing that can tell us something is right or wrong. Just hearing how a drill is performing, or an instrument is performing, can tell you about the health of the scientific payload. So there is also a very useful aspect of having an instrument like that on board. Now, for everything else, we have all sorts of things. We have lasers zapping rocks and sending plumes of material up in the air so that we can analyze the plume that's being thrown up into the air. This is through laser. We will learn about the compositions of those rocks. We have many cameras, spectrometers, so we are going to look at lights in many, many different wavelengths to understand the morphology, the mineralogy, the composition. All of this is helping us put into context the different elements, features that we are finding. Our hope is to be able to find one day a sign that life started, but if we don't find that, we can at least understand the sequence of different environment that is going to tell us how fast Mars changed, for instance. How did it change? How variable is the climate? And these are not only lessons from the past, but they are also lessons for us to understand what is, how can we forecast the future of Mars? How Mars is changing, how drastically it is changing. So, and also some experiment that will tell us, how we can prepare for human exploration.
Yeah, well, and if we do discover life on Mars, even if it is microbiotic, what it will mean for you, what it will be for the Earth as well.
Yeah, it's there too. You know, there are many different scenarios. I think that the most difficult scenario is not this one. The most difficult scenario is not to find life on Mars. And then you have to say, okay, when do we stop looking for it? I don't think that the answer is after that mission, because of course we're only starting and we need to learn more about the environment, etc. So that responds to your question why we continue to do that, because we need to understand the environment very well to try to extract a biological signal from the environmental background. But I guess that there are a number of options here. Let's assume that life appeared on Mars, and if it has appeared on Mars and it's different from us, then the significance is profound, because now you have 2 planets out of a solar system of 8. That's 25% of those planets that are showing sign that life is here. Yeah. And Mars looks barren and desolate now, and there are some smaller moons in the outer solar system that are a lot more active than that. So you can imagine that if we discover life on Mars, we are bound to find other life in the solar system. That would be my bet. And then there is also the possibility that Mars and the Earth exchanged material very early on. And as part of the formation of the solar system, there was a lot of debris and asteroid impacts and comets impacts. And the earlier you go and the bigger those debris were, and they were capable of throwing significant amount of ejecta into space. And we know from orbital mechanics that material leaving from Mars takes about 2 or 3 million years to get to the Earth, but ultimately gets to the Earth and land there. We have the Martian meteorites, so we have an evidence of that. And how do we know that they are Martian? Because they have air bubbles trapped in them, and in those air bubbles, they capture the atmosphere at the time when they are being ejected, right? And this air contains very specific isotopic signature that are unique to Mars. So we know without a shadow of a doubt that those rocks are coming from Mars. So that trip in that direction is possible. We know it, it happened. Mars threw rocks at us. That's not nice, but at least that's useful scientifically. And it's very likely that we did the same thing. It takes a little longer in that direction, but it's still feasible. So there is a substantial chance that if life had developed in one of those planets, that it actually was transferred into the other. What I like to toy with is the idea that maybe the transfer happened both directions, that both Mars and the Earth actually developed life independently, but still threw rocks at each other. And maybe we have a mix somewhere. And the environments were fairly similar early on. So it's not that, prebiotic chemistry or even early organism would have been stressed out, landing either on Mars or the Earth very early. They were very fairly similar environments. So there is this one there. And then there is another possibility. And this one is that life is not indigenous to either Mars or the Earth, but actually came from comets and asteroids. And we have a new model for the old theory of panspermia, considering what we are learning today, meaning that the seeds of life, all this organic material, etc., would be brought to planets through comets and asteroids, and then would find a favorable environment in some of the planets. So Mars and the Earth being, again, quite similar at the very beginning, there is a chance that independently things could have started and might have been fairly similar as well. And then there is another bigger perspective. And I like to step back when I'm thinking about that, is that we are talking about what's possible from the standpoint of orbital mechanics between Mars and the Earth, and say, okay, those two may have exchanged material, okay? But then there is the outer solar system. and the outer solar system, it's not that it's completely impossible, but it's a lot harder for material ejected from the Earth to go to the outer solar system and seed some of the moons out there, and the other way around. So if something happens in the outer solar system, it is likely to be very different. I'm not talking about the very different chemistry of Titan, for instance, but even for Enceladus or Europa, where you can understand the chemistry, except that it's cooler, then it has to be separate. But ultimately, if you are taking a 4.5 billion year perspective, we are all coming from the same solar system. All of these planets, it's all at the very beginning, the same chemistry and the same physics. So our family tree is there. This is the solar system. And everything else is just like developing one side of the family, the other side of the family, etc. So as a scientist, I'm very, very curious. And I'm really hoping that I will see the discovery of life in any of those places, or maybe all of those places, because we have mission to the outer solar system fairly soon as well. But I'd be interested to understand what's happening there.
Knowing about the neighborhood a little bit. In fact, Perseverance, I understand, is taking one of those meteorites back to Mars, isn't it?
It is a fantastic story. I love it. I really love it. You can imagine that rock thrown into space millions of years ago, landing on Mars. And basically, I'm not getting political here, but we're telling them, hey, you are going back where you're coming from. But I think this is, beside the joke, there is something there very profound as well. Because when that rock left Mars, we were not even a project in evolution.
Yeah.
And today, we have the capability to take that rock onto a rocket and send it back home. And I found it marvelous.
It's really amazing.
It's just showing, I think this is how we should see this, how the evolution of life on a planet at some point where we were nothing. And evolution could have taken any direction by the time that rock left Mars. But ultimately, here we are. And today we're capable of sending this rock back home. It is very cool.
Yeah, it's the same as happened naturally at the beginning between planets. Okay, and what about other stories, like what happened on May 30 between SpaceX and NASA that launched together this historic Crew Dragon capsule to the International Space Station? That's another subject, but what do you think of the private companies exploring the universe, now for tourism inclusive?
Yeah, in the grand scheme of things, I think this is a good thing. I do believe that partnerships like that will multiply the opportunities for science to start with. I am a scientist, so I'm seeing that side of the partnership. This is multiplying our opportunities. And also through competition, you are making the access to space cheaper, which is a win-win situation as well. The fact that space becomes more open to tourism, and we'll have to define what tourism means, because right now it's going to be so expensive that I don't think this actually, it doesn't register to me as tourism. You have to be very wealthy to be able to do that. And so I do believe that, in the grand scheme of things, this is where our species is heading. We are becoming interplanetary. We are the threshold of that. We are we are making our very first steps, right? So there is a little bit of everything. And I do believe that it's very positive. And at the same time, obviously, just because we're human, and we tend to do things a little fast and getting excited and maybe, not thinking through all the details, there are things that we do and probably shouldn't be doing just because we can do them. And when I'm saying this is with respect to planetary protection, respect to an understanding of, how we should approach planetary exploration. We could do that as a, locust in the field and just go and take whatever, or we can have a more reasoned approach to that. One of them is to say, okay, we have to be conscious, especially at this time, this particular time, where science is just trying to figure out whether life has developed somewhere else than Earth. It is very important that we are all conscious about planetary protection, contamination, etc. And planetary protection is not about preventing you from doing things. It's actually helping you figure out how to do them without taking the risk of contaminating results and biasing what we want to find. So the last thing I want, if I go to Mars and I'm searching for life, is to find, that actually I've made 150 million kilometers with my rocket to find terrestrial life, unless it was thrown there 4 billion years ago, and it's the reason why there is life on Mars, right? But I want to be able to figure out what happened to that planet. And right now, we don't have a good idea yet on how to do that. And there is a lot of discussion happening about, a reasoned approach. Exploration will happen. It will. It is happening. So it's not a matter of saying it should not, but how it should happen. And the private partnership is something that needs to be thought through, because this is something new. And NASA or ESA or any government agency, space agency, has rules about how to approach that, decontamination of spacecrafts and trying, to prevent contamination. And I think that as we are opening these two commercial partnership, then there has to be a global understanding of those rules.
Yeah, thanks. I have another question on other topic that is very interesting to me, at least. You got in 2012 the Women Leadership Association Award that recognize extraordinary women making significant contribution to world knowledge and science through exploration. In fact, you have been a great model to girls and young women, but it seems that you don't agree with gender quota laws. Could you tell us more about that, and also what you are doing with school students to encourage research in the field of astrobiology, please?
Yes, and thank you for bringing this up. I was invited back in February, in fact. You are talking about 2012, but I was invited to give an address to the United Nations in February of 2020, and that was about a young girl and woman in science. And I was invited to talk about gender bias and the difficulty not only to have women in science, but to, once they are there, to keep them there. In my address, I was mentioning how important it is that we have a structure that allow them to stay there, that they shouldn't be forced to choose between motherhood and a career, that there should be social structure to help that. And then I ended up talking about a number of things. And the quota that you are mentioning is something that I think is extremely important, because although men and women should be represented with equity, if you are telling me that you need 50% of men and 50% of women, and I am going as a science director to actually hire people because I need to fill quotas, I think this is another type of segregation and another type of another type of segregation. What I mean by that is that I want to be able to hire people because of their skill. People are not statistical quota. What is important is to give equal opportunity for men and women to go to the same school, develop their skills, etc. All right. And then we need to allow them to compete equally. And then depending on their skill and expertise, being selected. But what I want is for everybody to have the same right to compete. And after that, the best one wins. And it's not because I'm a woman that I'm going to take a woman and fill a position because I need 50-50. That wouldn't be fair for the man. You agree with that? What I want is to have a representation of skill, but before we can get there, the system needs to become more fair in the way it brings in women and give opportunities to women. So we don't need, we shouldn't be mixing quotas and equality. This is not the same thing. Equality in right, equality in competition is extremely important. Quota is another type of segregation. So this is the point that I made, and I think it's very important. I want any woman who is in my institute to be here because they deserve it. You know, they are the best expert in their field. And believe me, I have some, and I'm going to quote unquote, badass women here that know their stuff very well. And I have no problem having them. But if a man comes and is better than a woman, I am going to select the man. There is no reason for me not to do that, okay? So quota and equity are not the same thing. We should provide everybody with the same opportunities to succeed. This is where equality comes into play.
But then we come back to education. I have read that for you, it's also an important step towards that direction. So please tell me a little more about your involvement in the research of, what school students are doing in the field of astrobiology, what you are doing in that direction.
You know, I'm the director of the Carsegan here, and there is a director of education, and education is absolutely paramount to the Institute. And so we're engaging into summer programs and other programs where we are bringing in young people. And many of them are not quite decided yet about what they want to do. You know, this time, some people already know from birth, for others it takes longer. And at an age around, you know, when they are at the beginning of their 20s, we offer programs where they can come at the Institute, be involved in projects, and then try and understand if the scientific process is interesting. And if they are interested with that, then they have a first experience, they are developing networks. We have alumni, they can come back and they can connect with each other. So it's really starting the process here. We also have other programs that are involving young researchers at the PhD level, which is the Frontiers Development Lab. And this is a different program, but it's also a young researcher. And then very involved with school, with Girl Scout. We have a fantastic Girl Scout program at the Institute where we have tens of thousands of young girls who are now wearing patches that were developed with the SETI Institute. And so I found it fantastic. So everything starts with education. Everything starts with education. Girl, boys, doesn't matter. They are beautiful young minds, and children are curious. I think that hands-on experience, you know, being with us, personally, I've been taking students to the field with me, and oftentimes they're always excited by the idea of, you know, of an adventure, because it's an adventure when you're living in the Altiplano or in the Atacama Desert, and very, very quickly, you see those young people who are just they thought for an adventure, turn into very responsible adult, part of the team. And we are giving a hand here and there, and all of a sudden something changes in their mind. They understand that they are becoming an essential part of a bigger wall. And so that gives them tool. Whether or not they will be continuing in science doesn't matter. I would prefer so, because, well, this is what I do. I'm mentoring a young mind to hopefully make them, you know, like science. But if they want to go somewhere else, they can use those skills that they developed here in every aspect of life. Teamwork is always good. Leadership is always good. Management, giving a hand, being resourceful in a place where there is nothing much, you know. The next supermarket in the Atacama is not exactly next door. You have to do with what you have, not what you wished you had. And I think this is a great, great lesson for life.
Of course, undoubtedly. Finally, I have my last questions to you. There are many questions coming from the public in the different social media that are watching us. So here it is. I mean, as you're a scientist, but beyond that, is there a spiritual side on your missions, working in the middle of the desert, diving on the top of the Licancabur? Can you share your inputs during this period about?
My first, you know, my first comment on this is that in your sentence, I would remove the but, because I don't think that there is any need to separate science from spirituality. I am not a religious person, and I don't think that has anything to do with that. I think that religion can be a great school for spirituality, but I am not a religious person. And I found that these incredibly open spaces, limitless horizons of the Andes, to me, they lead to a lot of introspection. And also they've helped me focus on, you know, those questions about when you are looking for life, you can't work with the, how am I going to search for life? But then this question becomes very, very quickly, what am I looking for, right? And when you do that, then you are heading towards a different question, is really then what is life? Because if you're really looking for something and you cannot respond to, you know, have a definition for what you're looking for, then you're in trouble. Mm-hmm. Or at least you are setting yourself for a lot of ambiguity when you are going to, you know, find evidence. And so little by little, although it was always present in me, this is a part of the questioning that has become a lot more important in my life and in my scientific life as well. I think that now the time is ripe, because it seems that a lot about the nature and origin of life, the questions that we have, may have answers not in biology, not in astrobiology, but interestingly enough, for the past 15 years, quantum physics, neuroscience, artificial intelligence, and information technology are starting to show that, well, there is a lot more. I'm not going to say than just biology, but biology might just be the typing of life. The origin and nature of life is something different. And quantum physics, cosmology, and neuroscience are teaching us a number of incredible things about, all right, what do we consider reality, for instance? It all starts with that. And it seems that reality is only what happens between our two ears, right there. Explain to me how our brain can act as a quantum computer at 11 dimensions when we are living in a 4-dimension world, the 4th dimension being time. It may be that reality only exists there, right? And that the basic core of everything is really, when you are going back to the quantum level, the smallest possible level, is about energy and information. Everything is energy and information, and it becomes information only when there is a consciousness to look at it. So very, very quickly, you start entering different realms. And today, we are seeing the convergence of quantum physics, neuroscience, questioning the reality, questioning what is life. And when you do that, all of a sudden, it's like everything collapses. There are no boundaries anymore. And some of the theories like biocentrism, which is probably one of the end member theories, is telling us that we are living in a conscious universe, that actually life is a product of this consciousness. Other theories say the other way around. Personally, I think that they co-evolve, and it's all a matter of complexity. What we are seeing around us is just energy and information wanting to get more information. And so complexity is born from here. But that, as an astrobiologist, I think of all these new theories and I take the questions of astrobiology back with that perspective. And then I say, okay, so if the universe is alive and conscious, then I'm not searching for life anymore because it's everywhere, right? We don't need to look for it. It is, the universe is alive, but I still can search for the manifestation of its diversity and complexity. And this is what we are doing. But I think that it's just a matter of perspective. And as far as I'm concerned, I don't think we need a definition of life, especially if everything is alive. You cannot define everything, right? But we can define life in specific ways depending on the very specific question that we are asking. And I often take this example of a postcard, and you have a landscape in that postcard, and you can define that landscape through the sky that you are seeing. This is going to be true. You have a sky, right? Or you can define it by the trees or by the hills or the houses. All of this is true, right? Or you can define it by the whole landscape. The definition of life is going to stand true depending on the type of reference you need at any given time. And I think this is what we have to live with. And especially if everything is alive and information and energy are transformed at the quantum level, then what you and I are still energy and information, which means that by only looking at something, we are modifying the experiment. So you know how fast it is to go from empirical science to spirituality without having to break a sweat. And then that will be my closing comment on this, because I know that there are questions. Simply speaking, I feel very comfortable personally to jump from one to the other, and I have no biases, and I can do that at any time, because I think that science is here to help us measure and understand the universe through what can be measured, whereas spirituality and intuition help us understand what cannot be measured. And if we are separating those, then we are missing a lot in terms of what could be understood in the universe. At least this is my view on things.
Amazing. Thanks so much. It's incredible. Thank you so much. This is a time for the public, so I'm going to start with them. There's one question coming from Spain. Rafael asks, when do you think we could have the technology to discover liquid water on exoplanets?
So there are a number of ways that water can be detected already. It's just because you can detect some saturation in the atmosphere. And you know that the presence of water in some amount and concentration is going to tell you that something is interacting between the atmosphere and the surface. So there are already a number of exoplanets that are very, very good candidates for ocean planets.
Great. And next, another question that is impossible to avoid. Pedro asks in YouTube, by when do you think humans will land on Mars, and when we will inhabit the Mars planet more permanently?
And this is a very, very a good question, and it's a very actual question. So there are a number of things. Obviously, giving ourselves a deadline is a good thing because it pushes technology, it pushes progress, it helps us figure out things. We also have to come to some reality here. We still have to wrap our heads around how difficult it is for a human to stay for a very long time in space without having health issues. You see, the astronauts are developing a lot of health issues. And then once you are on Mars, there is nothing right now. We'll have to start from scratch. So one way of approaching this would be to do what we've done with the polar stations on Earth here, which is to make some, permanent bases on Mars, but with people rotating and starting to incrementally, a little bit like the space station, where module by module, you're increasing the size of your colony. Shipping 1 million people right away is not something that we can do. We don't have the technology for that. Ultimately, there will be human on Mars. This will be happening. The starting of the colonization is going, in my view, to be more of a little by little, thing. Now, having said that, one thing is going to be a game changer, is that if we do make a discovery in propulsion systems. So if all of a sudden we can reduce the time it takes to go to Mars, because one of the issues is that it takes 6 months, in the best case scenario, to go to Mars. And in 6 months, you will have health issues. When the astronauts are landing on Mars, they will be in absolutely no physical shape to get out of the capsule for at least several weeks. This is the reality beyond the movies and the Hollywood things. This is what it's going to take. But if we can make substantial progress in propulsion systems, if we can go faster and shorten the time it takes to go to Mars, then a number of things become a lot more feasible. Not only the transfer time for the astronaut, but also the time it takes to transfer cargo, for instance, and to take care of them. Or if there is a problem on Mars, bring back astronauts if we don't have the possibility of taking care of them at the surface of Mars. Mars is not the moon. The moon is our neighborhood. We are fairly close and it's big in our sky, and the Earth is big in the sky of the moon. Mars is far away. We are a tiny dot. Imagine when you are coming out tonight and you see Venus in the sky. This is how the Earth looks from Mars. It's a little dot. So hopefully, in a few decades, I've heard things like, in 10 years, 15 years, maybe the first human to go there might be in 15 years, 20 years, I don't know. And again, that depends on discoveries, etc. Can be faster, but on average, I would say that in terms of colonies, it will take a little longer. But where's the hurry? I think we need to do things properly. These are our first steps as an interplanetary species, and we need to think this through.
Before that, there's another question coming through YouTube from Sergio. If there is life on Mars, how will it be studied? Should it be brought here? How will it be maintained there?
How will be?
How will it be maintained?
Oh, maintained. Oh, you're talking about extant life. So number of things here. We're talking about a sample return mission, and Perseverance. The goal of Perseverance is to actually cache samples and try to figure out samples that can be brought back to Earth so that we can learn a lot about it. And then again, planetary protection doesn't go only one way. We are not trying to only protect Mars from us, but we're also trying to protect the Earth from potential contamination. So there are right now plans that are being devised to possibly have those samples stopped in the equivalent of the ISS, if the ISS is still there and working. Who knows, maybe by then on the moon. And in terms of, in terms of extant life, which means that not fossils, but life that might still be here, which we don't know, then I do believe, and this is coming from experience in the field, that I would like to prefer to leave that life there for a number of reasons. The first one is that as soon as you are taking a sample and you are preparing it for transfer, that sample is being modified. And if you want to learn anything about, pristine properties, etc., you want to keep it in the environment it is at as long as possible. And then the methods and techniques to analyze those samples, it might be better to have a lab on Mars where we could have, sterilizing condition right there, where we have the glove box, where we have all the things that need to happen right there. That would be my personal, view on this. But for rocks, like Perseverance, there are sample return missions that are being planned. And, when people think about that, obviously contamination is on top of everybody's mind right now. See, this is what I live with, like everybody else. We have to know something is that, things like viruses, they co-evolve with their hosts. So yes, we are being attacked by viruses that are developed on different species, but species have been developing on the same planet for 4 billion years. We have a common environment, right? Mars is not a common environment. And the only maybe exception, and again, I am not a biologist or a doctor in medicine, so take this with a grain of salt, which should be fairly easy to do in Chile, right? It's that if there is any parentage between the Earth and life on Earth and Mars, then we might want to be a little bit more careful. But, scientists are not reckless people. They are not going to do things that shouldn't be done. And these samples will be taken care of and conditioned in a way that poses no threats.
Thank you so much. There's more questions, of course, but we are out of time. Thank you so much, Nathalie.
Oh, you're very welcome, Valeria.
I interrupt your Spanish, sorry.
I can do that.
Gracias, Nathalie, por acompañarnos hoy. Ha sido un placer, muy interesante, pero llegó la hora de despedirnos. Esta fue una actividad presentada por Puerto de Ideas y Escondida BHP. Quiero dejarlos desde ya invitados al martes próximo, a la misma hora, a una imperdible conversación. Esta vez será entre el escritor y guionista venezolano Alberto Barrera Tisca y el periodista y crítico de cine, el famoso Ascanio Cavallo. Muchas gracias, buenas tardes para ti, Nathalie, buenas noches para nosotros. Adiós, gracias.
Chao.
Chao.